Alright, let's do another problem. Today we're going to be working on this one. Hopefully it goes a lot better than last time. Anyways, number 190 on LeetCode, reverse bits. Reverse bits of a given 32 bits integer. Same thing as before in terms of two's complement notation, stuff like that. Okay, the input must be a binary string of length 32. Okay. Um. Okay. Is there a better way to do this than just, like, turning it into a string and then flipping it? That's like the first thing that I was thinking about. Like, turn the value into a bit string, reverse it, and cast it back. Let's see if the... Because it's been a while since I've done a bit manipulation one. Bit string. Or maybe there's a bitwise information. Oh, I mean, I could I just do that? Let me just return 0 for now and just see what this prints out. Let's see. None of the following candidates because of type receiver. Big integer. Inverse. Is the input oh, that might be a problem because the input is just a straight up integer, right? Or it's like just the string. It's just the string of bits. Yeah, so I get that. Well, that's a good question. Let's see. I guess we can't just invert it like that then. Let me actually check out. Should be a sandbox. Gonna be playing with version 1.3. Just gonna grab this. Can I just do that? Probably not gonna like it that much. We'll see. Wonder if this bitwise operation can only apply then to certain values. Inv isn't a thing. Was this added like in one of the later versions? Oh, that sucks. Okay, let me check the... So int isn't a thing. Unless maybe I was just not doing it right. Let that run. If I recall, there was some way to turn that into a string of bits. Or is that a Java thing? That might have been a Java thing. Yeah, looks like it's not particularly happy about me doing this. Let me actually check it then. Java into bit string dot to binary string. And this is just integer. Right. And this returns a string, right? I assume that it returns a string. Yeah, it's not happy about that. I'm assuming then that maybe this bitwise operation was added in a later version of Kotlin. Is there a way that I can change this to be like the docs for a previous version? I don't know, maybe not. Let's just see how fast the original let's just see how fast this is. To int. Let's see. And if this works, to int. Is there no? Should be a to int, right? Input string. Oh, it needs to be interpreted as a binary string. Let's see. Java binary string to int. I'm not looking for JavaScript. Binary to decimal. Parse int. Parse int seems to be a way to do it. Parse int. Base 2. Let's see what that gets us. Not quite. Let me actually just take this part again. I'm pretty sure the actual output was correct. It's just that this parsing part, this last part to convert it back, is actually incorrect. 0, 0, 3 ones, 0, 0, 1, 0, 4 ones, 5 zeros. Ah. We lost a ton of trailing zeros, surprisingly. This the binary string hasn't been very That's awkward. So this to binary string method seems to cull a lot of the trailing zeros, which is not what we want. Yeah, in fact, it actually calls all of the zeros. Hmm. Oop, did not mean to do that. To binary string. Returns a string representation signed in base 2. Let's see. The unsigned integer value is argument plus 2 to the 32. The argument is negative, otherwise equal to the value of the argument. Value is converted to a string of ASCII digits in with no leading extra leading zeros. Hmm. Hmm. Looks like there's an overload of 2 string that lets us do the radix, but does this do trailing zeros? The magnitude 0 will be represented by a single zero character 0, otherwise the first character representation will not be the 0 character. Hmm. I'm guessing that this doesn't actually quite work. And this should be base 2. This probably won't work either because it says that the first character cannot be 0 unless it is signed. Okay, this is turning out to be an interesting puzzle to solve. The problem really comes down to the fact that really comes down to the fact that there isn't wonder if there's a way for me to convert it into trailing. I could just append it. So if I did 2 binary string, right? We can say like val binary string is equal to integer dot 2 binary string n. And then val base value is equal to integer dot parse int of our binary string in base 2. And then for I in binary string dot length to 32 base value times equals 2. And this is inclusive, so I probably want to do this 31. Let me actually, this needs to be a var then. And then I'm going to print it out to see where we're at that point. Well, looks like we overflowed. We want to reverse it. I want to start by doing a reverse. And that looks correct. But I want to do a couple of other values just to see what it, so I can see if it breaks. Looks like it did. And why did it break? So this one isn't the problem. We can print line on the binary string just to make sure that it's fine. Is this number just too big for an integer? There's no way, right? Is that bigger than what is possible? Also, does parse int base 2 is it signed or unsigned? Looking at this with the trailing 0 or with the leading most significant bit of 1, I'm assuming that it does assume that it is unsigned then. Is this value too big? It shouldn't be, right? Because it's because it fits within a 32-bit representation. But it's not having fun. The value represented is not a value of type int. Character of the string is not a digit. Something like that. Radix is either smaller than min radix or larger than max radix. Argument is null or is a string of size 0. No, it's not. What's the max int again? Max value? I guess I'm pulling up the calculator. 2 to the 31 minus 1, which is this value. And we want this value. So it is bigger than a signed it is larger than a signed integer can handle. So, this is a signed integer. Example 2, the input represents a signed integer -3, and the output represents a signed integer output that. Problem is that it seems like parse int doesn't like overflow, which is unfortunate. Also, apparently there's just a reverse function in here. How did I miss that? Let's just comment everything out first. Val base value is equal to integer dot reverse n. Yeah, it's just here, but does it actually work? All right, cool. 2-line solutions. Okay. Spent like 20 minutes just to figure out that Java has a method that actually does work. Very nice. I'm not actually sure if this is fast, but I'm assuming that it is because just Java standard libraries, right? I'm not smarter than the people working at Oracle. We'll see. We'll see how fast it is. But I think this method actually is probably viable to a certain extent if we just reverse the string, and then we could technically construct it character by character. We start with, and we could like write our own interpreter of this parse int method. We could just go through this string in base 2 technically, and just assuming that it's a signed integer. If the leading digit is 1, then you have to represent it as a negative. But if it's unsigned, then we could just go through it as normal. I mean, I guess we could probably just do it the same in both cases, right? Um, Assuming that Kotlin or Java, whatever the JVM sort of underlying code is, the bytecode, assuming that it just overflows the integer, right? We could just keep on multiplying by 2 to the whatever power, um, or adding it on rather, each for each character, and that could be a viable option as well, right? We could construct this all by ourselves. It seems like this parse int just really isn't happy. Um, Looking at the documentation itself with the toString in, where is it here? It looks like it is unsigned. It is unsigned unless you add that sign message, which is a bit unfortunate. I mean, you could also just do something like a if not sure if you could actually do that. I was gonna say like if it's the leading, if the most significant bit is a 1, then you could tack on a negative at the beginning of it. You could append it, or I guess prepend it, right? Um, Not sure that would work, but no, you'd have to do a negative, and then you'd have to take the base string, the base binary string. You take the base binary string and whatchamacallit. Take the base binary string, add 1, basically do the 2's complement of it, um, and then you would parse that. So it'd be a little bit weird if we did it manually, but if there's a standard library function, then just use that instead, I guess. Ooh, but it's not terribly fast. I wonder where the bottleneck is happening. I mean, is there a way to see like what this is actually, or what this verse, what this is actually doing? Because I mean, if it did, then that would be better. But I'm not sure we can actually make this faster. Because the problem is that if we did it in our way, right, we'd have to cast it into a string, we'd have to reverse everything ourselves, and then we'd have to parse it ourselves. And this would all be in the context of the overhead that Kotlin itself brings, that the functions bring, and everything else. If the function is called many times, how would you optimize it? That's a good question, though. And maybe that's where the optimization actually happens. What you could probably do is maybe do something like you could use a data structure to hold a reference to all of the bytes. All of the bytes, which are all the bytes and their inverse values. And once you have the bytes inverse value, then in that case, what you would do instead is that rather than going through each character, you basically go through each byte and you add up the inverse multiplied by the amount. That's one way to do it. And that way you would sort of save on operations, I suppose. You could probably go even further beyond that, but I think bytes, or rather, maybe not even bytes, but like 4 bits. I think they're called nibbles. Um, Basically, you just have every representation of those, and you'd have 15 of those, right? Because you have 4 bits, so you can have up to 0 to 15, or yeah, I guess 16 sort of combinations there. 16 combinations, and then you just have a table for that, and then you just go through each 4-bit chunk, and then add up the representation value multiplied by the. I guess you'd be working in some different base then at that point, but basically you just do that instead. That's one way to do it, I think. Reversing the order of the bytes. Is there anything fancy that we could do with that? Reverse bytes. I mean, I don't think that would actually work. Because that'd just be swapping like this with this and then this with this, right? Because 8 bits to a byte, so you have 4 of them total. I mean, you could do like for each 4-byte chunk, you just calculate it and you add it up there. That also works. And that might actually be faster. I mean, you could do that. But I think this is where I'm gonna call it for today. I don't think bit stuff is necessarily something that I'm particularly interested in. I'm not like trying to go into quant or something like that. That's not really something that I'm interested in. And this is something interesting, I think, to talk about, where you could technically reduce the number of operations if you just hold a reference to those values reversed. But it's not necessarily something that my goal ultimately is probably to get into some higher level stuff. I'm particularly interested right now in mobile, in backend stuff, things like that. So this sort of thing I don't expect to come up in interviews a lot in that sort of area. Could be wrong. Maybe I'll get surprised by one of these problems, and maybe I'll have to walk through and actually code one of these up in the future. But yeah, this is where I'm at, and this is where I'm gonna leave it for now. But other than that, I hope you learned something, and I'll see you for the next problem. Okay, bonus content time, I guess. I decided that why not just try things out and see what works and what doesn't. In terms of this, in terms of a more manual solution, right? And apparently this is just faster. This is way faster, apparently. So basically what I'm doing is I'm taking the binary string, just the binary string, because this for each index sort of works like in reverse already, because it goes left to right, whereas binary you're supposed to be right to left reading. And we just realized my camera's reversed for that. But in any case, so that's why I'm just doing that, not reversing here. And then I am checking each value. I am checking each value to see if it's a 1. In that case, I'll take the 2 to the index that we're at and turn that into an integer. This is a little bit wasteful, but it gets the job done in terms of math pow. Everything needs to be a double. However, if we're at the last integer, for some reason there is an off by 1 error, if I had to imagine, yeah, that's probably because of the fact that the max integer value possible is 2 to the 31 minus 1, right? So we had to add 1 at the end in order to make it right. We also then have a little bit of a catch-up thing to account for the trailing zeros. So this is just checking the bit string length until 31 inclusive. And for however many zeros that it's missing, it just multiplies the value by 2. Because it won't get rid of the ones, because obviously those represent some data, right? But the zeros technically don't represent data to a certain extent. Of turning it into a binary string looks like Java likes to call those the trailing zeros. So we have to add them back with that little thing, and then we return the base value. This is 81.82% faster than the other submissions, so about 100 milliseconds exactly faster than my the previous sort of basic solution. However, it does take a little bit more memory. Might be a trade-off there to consider, but I mean I'm fine with this solution. So yeah, I guess the manual solution is faster than whatever the heck Java is doing in that they integrated in version, what was it, 1.5. I don't understand why, but you know what, we'll take it.